All right. I'm here with 52 weeks of AWS, and I'm still continuing to do AWS developer certification. I'm on module 11, which is developing solutions with AWS step functions. So let's dive right into step functions. So, a few things to keep in mind here with microservices are that they are an architecture for building distributed applications. So that's one of the advantages of a microservice, in that a monolithic application can be extremely difficult to debug. Like a lot of my career, I've had to deal with monolithic applications, and it's almost like a Jenga tower. You touch one thing, another thing changes. And so often it's difficult to even know if the thing you did was the real root cause, right? But with a microservice, one of the advantages of it is you can dive right in. You can figure out, oh, okay, here's exactly the component that I'm trying to solve. And then if you create multiple microservices, in theory, each microservice is really easy to understand what's happening inside of it. And then you can build out a giant distributed system. So, in a nutshell, how do you build a very complex system? You build lots of simple systems and then build those on top of each other. So one of the problems though with a distributed application is that as the complexity gets higher and higher, there are many things that can go wrong. And so, for example, if a function has an error for, a timeout or exception or et cetera, you need to figure out a way to coordinate what's happening within this distributed system. And so this is where things like step functions really start to play a huge role, is that it's a way of orchestrating a layer on top of all of the different components so that you can understand what's happening, and you can track essentially what goes in, what comes out, and then you can channel that throughout a series of other pieces of code. And really, that's one of the advantages of step functions in AWS, is that it does give you incredible instrumentation and monitoring. And one of the ways I like to describe monitoring and instrumentation is that it is essentially data science for software engineering. So if you believe in data science, you should believe in monitoring and instrumentation. So let's talk a little bit about this. So what is a step function? It's a web service that enables you to coordinate a distributed application, a microservice with a distributed workflow. And some of the coordinated components can be triggers, it could be errors, and you can, again, diagnose exactly what went wrong in each of the states when you use a step function. So some of the benefits would be that you can build an application very, very quickly. And so I think that's one of the probably the key takeaways, is that because you have this JSON-based structure where you can put a state, you can really, really quickly build out a application. Another one is the ability to scale and recover reliably, because each of the computes is running something like a Lambda function underneath. You actually have that scalability built into it. And then also, it's really simple to evolve an application, like a very complex application, because each of the pieces are composable, right? So you can pull things out, change state, do try, retry, rollback, etc. Now, in terms of workflow coordination, a few different scenarios here that work with step functions. One of them would be sequential. That's probably one of the easiest ways to do a step function. So step A, step B, and another one would be running things in parallel. So there's a lot of advantages to that, right? If you wanted to build an easily parallelizable system, you could build that out in step functions. You could also do things like a task based on the data. So if there's a certain input that comes in, you could pass some of the input to A. If it's a different input, it goes to B. A different one, it goes to C. You could do try catch behavior. You could do a retry. So the retry would come into play with maybe like monitoring a job. And this happens a lot with batch computing, where you'll do some kind of batch task, and the task could take from 5 minutes all the way to 5 days. And so what do? You just hang out and wait for your application to finish? Or what you can do is you can have something periodically retry. And then when it's done, it could send you a notification that says, okay, the batch job is complete. So let's go ahead and dive into how an AWS step function works. in a nutshell, you define a workflow or state as a series of steps or states in transition, and then all the work inside of it is done by a task. And the task itself, in many cases, would be a Lambda. And what's nice about this is that it's really simple to build a Lambda. And so you can build this incredibly complex system by building on top of this idea, right? Step or state, a transition, and then you have a workflow or state machine, and you can visualize and track it inside of the console. So how would you actually go through this? Well, you could as well define a state machine using the Amazon states language, which is essentially JavaScript object notation or JSON-based language. Very, very simple to understand. Essentially, you have comments, you have a start at, you have states, you have whatever it is that you're doing inside of it, and you can get a sample of it automatically by just clicking a step function itself. It'll give you a starter code to give you a place to build this out. When you're running the state machine, a few things to keep in mind are that when it started at the top level, it would be start at, and then after the step function runs a particular state, it then adds the value into the next field to determine the next state to advance to. And this is essentially the transition for when the step function runs. And then when the system reaches a terminal state, like it could be a succeed or a fail or an end, then the state will stop and it will return back the result. So state types, these are a few things to be aware of. There is a task. So that would be a single unit of work. This is probably the easiest thing to get started with, and probably where I would recommend using step functions. There's also choice. So again, you could be, depending on what kind of task you're building out, you could give someone different pathways that they go down. There's also a fail, which would be stopping a state and marking it as a failure. So this could be, again, part of maybe a batch monitoring system. A succeed, so this would be when a state is successful. Pass would be it passes its input to the output without performing any work. Maybe this is like a dry run system that you could have. Like you could have the full system and then you could have a dry run, and it would simulate maybe some very complex action, and then it would be a form of integration testing. You could also do a wait, which would delay from a continuous time. Parallel, so parallel branches for running state, and then map, which would be dynamically iterating a step. So in terms of a task state, a few things to keep in mind that are important when you're dealing with it. And so in the Amazon states language, a task itself would use essentially a Lambda function inside as the resource, and timeout would signify how long it'll actually take for it to run max. And then there's also the concept of a heartbeat. And so a heartbeat, what it does is it allows you to actually get a feel for, essentially whether the system is actually working or not. And then finally, when it's done, it can go to the next state. In terms of a pass state, if you look at that, it's going to pass its input to its output without doing any work at all. And again, it's really useful for doing debugging. That's probably one of the better use cases for a pass. Now, the choice state, you would have to specify type choice, and it could be, for example, a comparison. So, two fields that specify an input variable to be compared, or it could be, a next field, the value of the field must match a state in the state machine. But in general, a choice, what's nice about it is it allows you to build the logic without necessarily having to implement that inside of a Lambda function. Then in terms of parallel state, it's actually kind of an exciting state for step functions, because it allows you to build easily parallelizable systems just by using step functions. A wait state would be something that would be really good for a job, right? So you're waiting for some period of time, and then afterwards, then you transition to the next step. Again, it could be like, the wait state could be maybe waiting for a job to complete. In terms of a succeed and fail state, these allow you to stop running a state successfully. And so in a particular scenario, a fail state could stop the running state and marking it as a failure. And so you could even put inside of it a cause. So, like, for example, a custom failure string that says, we tried to train a machine learning job and it didn't work, or some other thing like that. An error would provide an error name that could be used for maybe retry or catch logic or operational logic or diagnostic purposes. And so what's really, really helpful about this is that because you have really good instrumentation, that these succeed and fail states can be invaluable as you're prototyping out a production system. All right, so let's talk about how to actually use them in the real world. So what are the use cases for it? In general, data processing is probably one of the strongest use cases for step function. So if you're a data engineer, an AWS step function for your cloud platform is going to be a very useful way to build out data engineering pipelines. If you need to just generally automate tasks, right? Like you're just scripting things, and it in fact works quite well with Python, which is also really good at automating tasks. Switching from a monolithic application to a more microservice architecture to do application orchestration, transcoding media files. So there's a lot of people that are doing things with media now. Transcoding, which is a very time-intensive operation. This would be a perfect use case for something like step functions because it can wait and it can show you exactly what happened. You could also do sequencing batch processing jobs. You could publish events from serverless workflows, coordinate container tasks in microservice. You could access a database if you have a full serverless database architecture. You could sequence the steps of a machine learning workflow. So potentially you're going to do some kind of transformation step and then maybe hyperparameter tuning and then talk to your machine learning system, and then also the coordination of ETL jobs. So I've used this quite a bit myself with step functions, is the extract, transform, load workflow, because it's so simple to get started. Now, another example would be an activity state machine use case. So like if you wanted to manually approve something, so let's say you wanted someone to, send out some kind of approval form, maybe like a law firm, or, maybe some kind of inventory or purchasing department. You would create this whole workflow, and then someone would either approve or not approve, and that could actually go through a step function based workflow. And so how would you do this? You would build in a manual approval process. In the type, you would be a task, and then in terms of the resource, you would put in your Lambda function. Now let's talk a little bit about the API. So not only can you build out a step function that orchestrates out a whole system, but what's even cooler is that actually you can orchestrate the step function itself via the API. And you could use either the command line tool API, which is really helpful, or you could also use the Boto 3 API or use some other language. So let's talk a little bit about the different API components. So you can do create, and this would be upload a state machine definition. So if you wanted to programmatically create a step function, maybe even dynamically, this would be kind of a cool way to do that. And I could see like you could really create some sophisticated kind of on the fly step functions to do something and then rip them out when they're done. Also start execution. This would be a great way to use step function APIs, basically tell a step function to run. You could also do a stop execution. So, basically return the date the state machine stopped. Also, you could find all your state machines. So if you are going to, again, maybe programmatically build tons and tons of step functions, one of the things that you could do would be to programmatically list all of the state machines, the runs, the activities. You could also describe what's happening with the state machines, and then you could also get the execution history. So, for example, if you had a bunch of step functions running, you could say, "Hey, I want to show all the failures for step functions," and maybe build out a dashboard so that the operations team could look at the execution history and maybe triage those step functions and decide what to do. Now, running the state machine via API is probably the no-brainer, most common way to call step function, which is you have this really complex step function, and you just call an API, and that triggers the whole thing. Another one that would be pretty useful too is having an API gateway in front, and that way you have this really complex interaction, and then your REST API will then trigger it, and then you could actually do this via an API. So let's talk a little bit about some of the limitations with a step function. So in terms of general limits, would be things like the names, right? So you'd have to have a certain naming convention. Also, limits related to account, like the maximum number of registered state machines. There's also limits related to the run, like how long it can actually run. Also, the task itself, API action throttling, and then state throttling. So, in a nutshell, I guess what I'll mention about step functions is that it's one of my favorite things to do with AWS in terms of building systems. And I would say if you're a scripter, like you like automating things, you like using Lambda, you have lots of things that you do with Python. I would say step functions are a no-brainer if you haven't used step functions yet. If you're doing things with orchestration of any kind, like data engineering, web scraping, those kinds of things. Also, I would say a step function is a no-brainer. So I would say in general, if you're a person who likes to automate things and build really quick solutions, and you haven't yet used step functions, you're missing out. And I would also say if you like to use a command line, step functions are a great use case of your time as well, because you can build out this really cool automation workflow, and then whenever you want to, you can just trigger off a step function, and it can go through and build out what it is you want to build out. So that's it for that particular section. So I think I have a little bit of time, though. What I can do is start one more section, which is developing secure applications. And so let's go ahead and go into that. So I'm gonna share my screen here again. And so let's talk about developing secure applications here next. And so the idea with developing secure applications is that you want to build things in a way that allows you to not be embarrassed when you have some huge security hole that shuts down your company. And so how do we do this? Well, a few things to be aware of is the shared security model. I think that's probably the biggest thing, to start with. And with the shared security model, the idea here is that you're able to actually let AWS handle a lot of things for you, and then you handle some of the things yourself. And that's really the idea. And on the things that you're supposed to handle yourself, for example, your application logic, you're using encryption, as a best practice. So let's talk about securing the network connections first. So one of the ways that you can do this is through, things like SSL. And so what SSL does is it encrypts the traffic between a client and a server. And that's really the key takeaway here with using SSL. One of the problems, though, with this is the certificates. And so certificates themselves can be vulnerable for mismatch or people hacking them. Also discovery, so like making sure you have the individual certificates in your network, rotation and renewals. So like if your certificate is expired, that could cause a problem. Authorization, so somebody's got to approve and issue a certificate, and then they cost money as well. So those are some of the issues with certificates. Now, one of the ways you can handle this is with a service on AWS called AWS Certificate Manager, or ACM, which is a service that will let you provision, manage, and deploy a public and private SSL certificate for use with AWS services. And so with AWS Certificate Manager, that's really one of the ways that you can actually solve that relatively complex problem. So let's talk about how to manage application secrets. So this is also a very, very tricky one for a lot of people, is like, how do you actually manage your secrets? And so let's talk about some of the issues that happen with managing secrets. Like, I mean, the classic one that's a real problem is you accidentally check in your API keys somewhere, and that is a real problem. And so some of the issues are access and authorization. So, basically which user can do what. Rotation. So like you want to rotate these secrets and make sure they have a life cycle. And then where do you store them? And you don't want to store them in plain text. Those are really three of the issues. Now, AWS has something called Secrets Manager. And what's really nice about this is it allows you to have a centralized strategy for dealing with secrets. And so you can rotate things, retrieve database credentials, API keys, etc. And you don't have to have things, hard coded in your application, because you can just make a call out to the secrets manager. And so if you're an IT admin, you can store and manage things. Security administrator, you can audit, make sure that things are actually done according to best practices. And then as a developer, you can avoid storing the secret in the application. So how does it work? In a nutshell, here's a scenario. A database admin could create some credentials in the secret manager, and then they could use those credentials inside. And then the administrator could then store those credentials as a secret in the secrets manager. And then now the credentials are encrypted and stored, and you don't have to worry about them again. And then when the application itself needs to access the database, the application would actually query the secret manager for that custom secret. So what's great about this is that then there is no chance that the application code itself could somehow leak out those credentials. And then when the application would parse the credentials, then it would actually use that to access the database server. Another option here is something called AWS Systems Manager Parameter Store. And this is a different kind of secret that can be unencrypted via plain text values. And it can store basically secure hierarchical management, and it can store the values as either plain text or encrypted data. What about authenticating with AWS Security Token Service? So one of the nice things about a token service is that you can use the best practices to retrieve temporary security credentials, which is kind of cool. And then you don't have to share access keys between accounts. So one of the ways you can do this is by using this AWS Security Token Service. So you can have a short-lived access key ID, secret access key, or session token. It's limited, configurable. It can't be reused after they expire. So this really is a pretty cool way to have security, because it's essentially self-destructing. And it's only good for a little period of time. There's also AWS STS trusted users. So the federated identities are one of the ways that you can handle this. The STS key concepts would mean that with authentication, you could verify the identity of user authorization would be verify the permissions. And then in terms of standards, you'd use things like SAML and OpenID. Now, in terms of authentication with AWS STS, you would go through something like a identity broker, Authenticate, do maybe a second authentication, and then STS would use IAM to confirm that the IAM user is able to make the correct calls. Some of the things you can do with this API include assuming the role with SAML, getting federation tokens, getting session tokens. And you can see with CloudTrail that it'll actually track those users. So CloudTrail is a great way to figure out what's happening with your system and audit the security logs. Now, another service that I've used is Cognito, and it is actually pretty comprehensive in that it allows you to have authorization and authentication for both web and mobile clients, and you can synchronize data across devices. So there's a couple components that you can use. You can either use user pool this would be authenticated users, so user directory in Cognito, and it actually has sign up and sign in options for you. And it even has federated authentication as well, which is pretty nice. So you can log in with things like Google. And then there's also identity pool, which is temporary security credentials. So the user pool scenario would be you have, let's say, a mobile app and you want to authenticate into some part of AWS, they would get a token, and then they would be able to access that part of AWS. The identity pool scenarios would be, using some kind of identity provider like Google or Amazon, and then you would go through there and give that user, once they've been able to authenticate, access to the resources that the application is trying to give them. So really, that's it in a nutshell. I think I have some time here to just finish off the entire developer certification. There's just one more lesson left, so I'll go ahead and finish this off. And this will be deploying applications on AWS. So let's dive into this real quick and talk about it. So in terms of deploying, one of the best things to understand in terms of cloud computing is how to actually deploy something in a reliable way. And this deals a lot with DevOps, something I've written more than one book about. And in the cloud, your application isn't just an application, it's an application plus all the infrastructure you've actually got to deploy. And so one of the ways to talk about this is with DevOps, and really DevOps is about automation, right? And so you're automating things in a way that allows you to have a reproducible way to deploy your software. So the DevOps culture is basically, people over process and tools, remove, barriers between development operations, shared responsibility. I would even classify it in a more simple way, is that if it's not automated, it's broken. Some of the practices for DevOps that I think are really important to be aware of are microservice architecture. So instead of having a monolithic application, you break things up into a smaller piece. Also using continuous integration and continuous delivery. So if you're not using those two things, you're not doing DevOps, period, right? You have to be able to automatically test your code and deploy it, and then automate everything, as I mentioned before. If it's not automated, it's broken. And then infrastructure as code is another one. If you're not programmatically creating the infrastructure, then you're not following DevOps best practices. So in terms of AWS, the DevOps tools that are available include CI/CD pipelines, so things like AWS Code Build, microservices like the Elastic Container Service, Lambda, platform as a service offerings, things like App Runner or Elastic Beanstalk, infrastructure as code, so like CDK would be a great example of that, or OpsWorks or CloudFormation, and then monitoring and logging, things like CloudWatch, AWS Config, CloudTrail. So the big benefits for DevOps would be improved collaboration, rapid delivery, scalability, security, reliability, maintainability. So basically decreasing the probability of failure is one of the huge benefits of DevOps. So let's talk about AWS code services for CI/CD. And so with continuous integration, really the idea here is you take your code from a source control repository and you test it, and then you deploy it. And continuous delivery or continuous deployment essentially is that you're always having your code in a deployable state. So all of the infrastructure as code is built into it so that it can always deploy to a staging environment, a production environment, or some other environment. There's nothing special to do. It's built into the process of building your code. And so with AWS code services, if you wanted to use just only AWS services, you could use, for example, CodeStar, which is a cloud-based development service. You could also use Code Commit, which is source control. You could use Code Build, which is a fully managed continuous integration service. I mostly use of these Code Build, and there's also Code Deploy, which is a fully managed deployment service. But you could use all of them together to do CI/CD. Now, in terms of testing and deployment strategies, these are some important concepts. One of them is A/B testing, so you can test new features to gain insight to what is helpful and what's not. You could also do feature flags. This is kind of a cool concept to debug things in production. Like you could disable a feature to debug something. Canary testing. This would be like testing your code on random users. So you could deploy, let's say, to just 1% of the users and just see how it works. And then if it works for the 1% and there's no bugs, you could deploy to the rest of the users. There's also blue-green deployment. So you could basically deploy to all the users at once using something like a load balancer. There's also blue to green deployments with Route 53, which is the managed DNS service. You could also do it with EC2 auto scaling. You could also do it with serverless. You could also do a rolling deploy, kind of what I mentioned before, which is you could deploy to 10%, then you could deploy to 20%, then you could deploy to 30%, and then finally you could wait and then deploy to everybody. There's also AWS Elastic Beanstalk, which is platform as a service offering. It works with PHP, Java, Python, Node, .NET, Go, Docker. It's a great service for building things at a high level. Some of the components for Beanstalk really are just the same things you would do yourself, like a load balancer and workers and versioning of your code and configuration. There's also a CLI for Beanstalk, so you can do EB init, EB create, EB deploy. So it does work really well for building continuous delivery. There's also the permission model, so you could give it a service role. There's also CloudFormation, which is really the first iteration of infrastructure as code. And so it's a fully managed service. It has this concept of stacks where you can actually use those stacks to deploy in a predictable way and look at the instrumentation of those stacks. And it's a way to basically build out the entire cloud platform. So how does it work? You have a template, and then that template goes into a CloudFormation, and then you provision that. Some of the things that are involved in a stack would be the unit of deployment, how to update the stack, how to delete the stack. The templates are basically a text file that's either JSON or YAML format, and it's very verbose, right? So it's self-documenting environment, and they'll even have the version inside of there. So things like the format, the description, the metadata, the parameters, the transformation, all those are in the template. In terms of deploying with SAM, this is more of a newer one. This would be for serverless applications. With serverless applications, you can actually use a SAM template, and this would define your serverless application. You can also use a CLI to actually do this as well. So this can really help in terms of things like Lambda, where there's some tricky things about doing a deployment. And you can see here that a SAM will build out a template, and it shows you at a high level all of the things that are involved inside of the SAM template. So really, in a nutshell, that's it for the AWS developer certification. I was able to get through the last three items of it, and that's it. I think you're able to, at this point, study for the exam on your own and pass it. And the other thing to mention, probably next up, I believe would potentially be, let's go ahead and take a look at what I would cover next here. I think the next topic would be the data analytics certification. So most likely in a couple weeks I'll start on that. But thank you for paying attention for the AWS developer certification material, and I'll talk to you soon.